And hello and welcome to a OneClass and the OneClass stream. My name is Joey. I'm going to be your math teacher for this session. So what we're going to do today is we're going over this kind of journey of verifying solutions for frequently asked problems in secondary school math as well as in chemistry as well. So currently what we've been doing is that we've been kind of given this series of about 10 questions per hour, and we've been kind of verifying solutions and teaching you the concepts throughout these questions. This can range from anything between the secondary school math level and in chemistry, and also in the university and college level. For today specifically, what we're going to do is we're going to focus mainly on kind of pre-algebra, algebra 1, and the geometry questions of about 10 to 12 problems for those questions as well, and we're going to work through them as we move along. My name is Joey. I'm currently an Ontario school educator based here kind of in Toronto, and I'm currently helping OneClass verifying these solutions so that you folks at home have the best kind of videos moving forward. So let's get started up on these videos for today. So our first question is asking, can a rectangle be a rhombus? So a geometry problem here. Let me write this down on the right hand side here. Can a rectangle be a rhombus? So let's think about that for a second. And if you need a hint as to how to answer this question, you can always look at this kind of solution that they give you. But it's asking, can a rectangle be a rhombus? So we have to ask ourselves, what is a rhombus in the first place, and what is a rectangle? We have to ask ourselves, what's the difference between those two things? And that's kind of the crux of the question here. So I'm going to draw a rhombus. It might not be perfect here, but I'll try to draw a rhombus. So this here is my rhombus, and what it is it's basically a quadrilateral, so it has four sides. So this is my rhombus. So it has four sides. Two opposing sides are parallel. So you can say these two lines here, or that's not parallel, sorry, that's the same length. But these two guys here are the same slope, and these two guys also have the same slope. So I'll say opposing sides are parallel. That's how you spell opposing. Opposing sides parallel. And then we also have the interior angles here are not 90 degrees, right? This interior angles do not equal, or each interior angle I should probably specify here. So let's see, it's right here. Each interior angle is not 90 degrees. So it can't be so this here, so for example, this here is not 90, this here is not 90, it's not 90 as well, this here is not 90 as well. Now that actually, I think I did a pretty good job in drawing a rhombus here, which is nice. So this here is a rhombus, and what's the difference between that and a rectangle? So let's see, let's look at a rectangle here. And I have a tool here, so it's actually much nicer for me to draw. So this here is our rectangle. So again, what are the properties of a rectangle? Well, I also have four sides. I also have opposing sides are parallel, right? These two, the lengths of the rectangle are parallel, and the widths are also parallel, right? So I can say here that the opposing sides are also parallel. And what about the interior angles? If I look at the interior angle here, I actually have right angles, right? This guy here is in 90 degrees, 90 degrees, 90 degrees, and this here is in 90 degrees. So these are 90-degree interior angles. So that's the difference between a rectangle and a rhombus here. Interior angle here. So when we're asking, can a rectangle be a rhombus? Well, technically it cannot, right? Okay, yeah, a rhombus here, it says each interior angle cannot equal to 90 degrees, and rectangles have an interior angles that equal 90 degrees. So in this case here, we don't really have, based off these interior angles, it's similar, but but it can't be 90 degrees here. And what they did also here is they actually drew bisecting lines as well. So they bisect each other at right angles. So let me see if I can draw some bisecting lines for you here. One that goes here, and these are supposed to be 90 degrees here, but obviously, as you can see, it's not the best line here. And these guys are supposed to be 90 degrees, but as you can see, I didn't draw it nicely enough. So this here is supposed to be 90 degrees here. So it says here, the solution is saying here, each square is a rectangle, and a rectangle can be a square if 4 sides are the same length. That's true. Every square is a rhombus, and a rhombus can be a square if all angles are 90 degrees. Yes, that's okay. And then it says, thus a rhombus can be a rectangle if only the sides are 90 degrees, and a rectangle can be a rhombus if the sides are equal length. So basically what I said before about the 90 degrees, right? So rhombus here, it can be a rectangle if the angles, or if interior angles equal 90 degrees, and then it'll be a rectangle. And then the rectangle can be a rhombus if all my sides are equal length, right? So rhombus here, the sides here are of equal length here. So these guys are all equal, 1, 2, 3, and 4 here. Whereas this one is definitely not equal, right, for a rectangle. So a rectangle can be a rhombus only if the side lengths here are equal and not 90 degrees. Because if they're equal and 90 degrees, then it'll become simply a square, right? So I can say that it can be a rhombus if interior angles are not 90 degrees and side lengths are the same. And I also have another condition where it will be a square if side lengths are equal. So this here is my answer. A rhombus here can be a rectangle only if the interior angles are equal to 90 degrees. So therefore it will become a rectangle, or actually it becomes a square, because so this here is actually a square, sorry. It's a square if because all the sides are equal and the interior angles are 90. And it only could be a rectangle if my sides here are not equal to each other. So therefore it is so a rhombus here can be a rectangle only if so this statement here is wrong, right? It says, thus a rhombus can be a rectangle if the angles of the rhombus are 90 degrees. If they are, it actually becomes a square. So we would actually have to modify this side length for us to make this a rectangle. And a rectangle can be a rhombus if side lengths are of equal length, but it also, if they're equal length, then it becomes a square, right? So it depends if I modify these side lengths. So I'm going to say the solution here is incorrect because their last statement is no good. This statement, and we're going to quote them as well. Thus, a rhombus can be a rectangle if rectangle can be a rhombus is incorrect because if rhombus has all angles that are 90 degrees, it would make a square. If rectangle can also be a square if side lengths of rectangle are all length. Therefore, in order for a rhombus to be a rectangle, I would need the angles of the rhombus need to equal 90 degrees, and I would have to change my side lengths, and side lengths need to be modified. One side must be greater than the other. And I'm going to say a rectangle can be a rhombus if all sides are of equal length and the interior angles are not equal to 90 degrees. So this solution here is incorrect because their statement here is false here. So the solution here is incorrect. Okay, that's number one. Let's look at number two. It says, what are consecutive interior angles? I think I've actually answered this problem before. And what this is you basically need a diagram. And this diagram is actually really, really good. And I'm going to redraw this diagram for you and explain it. So I have basically parallel lines here. You can assume these two lines are parallel. And if I drew a line that crosses these parallel lines, called the traversal line, as stated here, traversal line, I would get consecutive interior angles. So this is a traversal line. Let me rewrite this here. I'll rewrite this here. So this here is a traversal line. And what this does is going to basically split my parallel lines into and I'm going to create angles using that. So I'm going to create basically this angle and this angle. And then also this angle and this angle. So the blue ones here are going to be, actually no, I'm gonna, let me redraw this here. Redraw these guys here. The blue ones are going to be opposite of each other, and the red ones will be the same here. So drawing this here, I can, what are consecutive interior angles? Well, basically there are angles that here are consecutive and they actually equal to each other here. So consecutive interior angles. And I'll show, and so it says here angle 1 and 2 are a pair of consecutive angles, and angle 3 and 4 are also a pair of consecutive angles here. So again, you can say that again, these two angles can add up to, basically the property here is that these two angles, the blue and the red one, add up to 180. So these two guys here, or actually it might be better if I number them because it might be easier for you to note here. So I was going to use some a color here, but it might be easier for me to note them. So again, angles 1 and 3 here. 1 and 3. Or sorry, the sum of angles. Sum of angle 1 and angle 2 or 3 equals 180. And the sum of 2 and 4 equal 180 here. So knowing this property and given this property here, if the sum of angle 1 and angle 3 are 180, and the sum of 2 and 4 are equal to 180 as well, then we can actually confirm that here that angles 1 and 2 are the same, and 3 and 4 are also the same. So that's kind of the property of these guys here. So angle 3 and 4 are the same, and angle 1 and 2 are the same. So say here, angle 1 equals angle 2, angle 3 here equals angle 4 here. So because, and this here is because, and you can say here the sum of angle 1 and angle 3, the angle 2 and angle 4 equals 180 degrees based off this property here. So this is the correct solution for this problem here, and this is the definition for consecutive interior angles. Okay, number 3. He's asking, what is the coordinate grid? Define the terms x coordinate and y coordinate and plot the points in the xy plane. Okay. I might actually use I don't know if I can plot points with Desmos, so I'm gonna see if I can. And I can show you using an actual grid rather than my sketchy drawing here. So it says what's the coordinate grid? So the coordinate grid here is this guy here. I have an x here and an xy plane, right? So maybe I'll draw only this out here. So I have a y and then an x plane, and this here is my coordinate grid. So I have, this is the x-axis, and this here is the y-axis. And it helps us define functions, it helps us define points and whatnot here. And we're given these specific points. We're given here, this is 1, 2, 1, -2, -1, -2, and -1 and 2 here. So let me draw this out here. And I hope I can make points here. So 1, 2 means that the first number here is the x-axis. So this is 1, and then we're going to go all the way to 2 here. So this here is a point. I cannot make this point. Can I just say 1, 2? 1, 2? There we go. Oh, we can. Okay, cool. So this here is a point on my graph, right? 1 and 2. Again, the first number refers to the x-axis, which is 1, and the second number refers to the y, which is 2, right? So this here is the point 1, 2, which means the next point, 1, -2, would be the same x-axis. So it's going to be 1 here, but I'm going to draw up it all the way to 2 here. So this is 1, -2 here. 1, -2. So it should be at this point here. So we plotted 2 points. Our next point would be, let me zoom out for a sec here, is going to be -1, -2, right? So it's going to be -1. So instead of here, I'm going to go towards this left side. This here is a negative part of the x-axis, -1, and then I'm going all the way down to -2 here. So -1, -2, you're going to assume that it's going to go here. So -1, -2, and as you can denote by the green kind of dot here. And finally, -1 and 2 would be, if you're going, the first number refers to the x-axis, where I'm going backwards to this left-hand side, this -1 here, I'm going all the way up to 2 here. So I'm going to go, this here is my last point here. So -1 and +2. And as you can see, it makes kind of a little dot. It makes a little rectangle here. So this here is my solution. And as you can see, this is the correct solution as well. So solution here is correct. Good analysis. So every time we're working with points here, it's just the first number here is the x-axis is x1, and the second one is y1. This guy here is x1. This guy here is y1. And these guys are like these guys here are very important when we talk about plotting points here. So we basically just find, oh, the x-axis is here. It's 1, and then we go 2, and this is 1, 2, and then we go up and plot a point here. And that's all we're doing when we're giving points. Number 4, define the symmetric property of congruence. So this is just simply just a definition problem here. So I'm going to scroll down here, and you can this is definitely just such a more of a logic kind of problem here. And what you can do here is it says here it's just simply a solution, right? So again, here it says symmetric property of congruence. If figure 1 is congruent to another figure 2, then figure 2 must be congruent to figure 1. So that's basically all. That's the symmetric property, right? So if I have some triangle here, ABC, and I have another triangle, hopefully about the same size, and this is DEF, and these guys are congruent with each other. So if I know that ABC, if I know that here ABC is equal to, is congruent to DEF, then angle DEF would also be congruent to triangle ABC. And that's all it's doing. If this triangle is equal to this triangle, then this triangle must be equal to this triangle. And that's it. So that's literally the symmetric property of congruence. So this here is the symmetric property of congruence. It's just saying if one triangle is congruent to another, then that triangle must also be congruent to our initial triangle. So the solution here is correct. Good analysis as well. Very easy problem here. Let's do number 5. It's asking us, is the square root of 150 rational or irrational? Okay, so I have the square root of 150. So this here, I'm going to write a math out. So this here is square root of 150. So it's asking us, is the square root of 150 rational or irrational? So what we want to do here, first we have to figure out, is the square root of 150 a perfect square? And in order for us to do that, we could actually use, a couple of strategies here. We could use prime factors. We can use long division to figure this out. So I'm going to use, personally, I like the simplified radical form better. So I'm going to take out the prime factors of 150 here. So 150, I know it's an even number. I'm going to take out a 2 here, right? So I take out a 2. I'm going to divide this number by 2 here. So 150 divided by 2 is, I believe, 75. And then with 75, I can break this down even more, right? So again, I know that I have root 2 first. Root 75 here is not even, so I can't take out a 2 anymore. But I know it's divisible by 3, right? So I'm going to take out a root 3 here. And then I'm going to get whatever 35 or 3 divided by 75 divided by 3, which I believe is 25. And then I know the root of 25 here equals 5, right? So I simply root 2 times root 3 times 5 here. So this would simplify to 5, and the root 2 times root 3 is simply root 6 here. So this here is my solution for the prime factor of 150. And now I have to ask myself, is this irrational or rational? And the answer here is irrational, right? And the reason why this is irrational here is because of this root 6 here. Root 6 is irrational. So root 6 is irrational. And the reason why is that if you did the long division of root 6 here, you're going to realize that this number is going to go, it goes on forever and ever. And we can solve for that using long division, but I'm not going to do that for you. But basically, if you can assume that if a square root here does not give you a perfect square, it's going to be a rational number. So for all integers only. So this here is our irrational number, and this here, the solution here is correct, right? The square root of 150 is irrational, and any square root that's not a whole number, not a decimal, is a rational number, meaning that the number never ends. So solution here is correct. It's good analysis as well. And then what we can do is we can utilize prime factors. Prime factors to see if the square root 150 is a perfect square. If not, then the answer must be rational for all integer numbers. So the solution here is correct. Number 5. So we have number 6 here. It's asking what is the surface area formula for a rectangular pyramid? Sorry. What is the surface area formula for a rectangular pyramid? So this one what you would do is you can either usually what math teachers do they would actually give you the formula for this for this problem here, but it really depends on kind of your teacher and what kind of their demands are. But what we're going to do is, I'm pretty sure what this answer is going to give you is they're going to help you derive this answer. So again, you don't really need to learn how to derive something in kind of pre-algebra and algebra 1. It's probably more reserved in higher level math. So what we're doing here is for a rectangular pyramid, and I'm going to skip the derivation here because it does take a long time, but maybe I'll explain it to you. Is what they're going to do is they're going to go through this derivation and explain to you that this here is your answer, which is very, very, very complex, which but I'll kind of explain how they kind of derive this answer here. So if you have a rectangular pyramid, which means your base here has to be a rectangle, right? And I don't really want to draw it here, so just because I'm pretty bad with drawing 3D objects, but right here we have a rectangular base, and we know it's going to go up and it's going to form a pyramid, right? So basically, when we want to find the surface area, we want to find the area of all of those sides together. So I have kind of this front, back, the two sides, and the base. So I have 5 sides for 5 faces. And the first face here, I know it's my area of the rectangular base is simply length times width, right? So this one's good. So this is the area of my base. And then, so I have the 4 sides there, which are the triangles here. So if I want to find that, I can use kind of this formula here. It says slant 1, or slant height for the front and back triangle, is obtained using the Pythagorean Theorem, right? So it's simply just, this here is simply just c squared equals a squared plus b squared, but it's rearranged to solve for simply just c. So it'd be c equals the square root of, this is a squared, so your height, plus your b squared, which is your base. And then you would get, and you would substitute the base here for half of the, we know that the base here is the half of the breadth, right? So this here is the half of the width, you can say. So we know that we can substitute our base here for w over 2, and this would give us our slant height. Similarly, for the other 2 triangles, so this was for the front and back triangle, these 2 are for the sides. So if I don't know if I can draw a pyramid here. It's kind of hard to draw a pyramid. Maybe I'll just show you a pyramid. It'll be easier. Okay. So if I had a pyramid, like this, again, it's the front and the back sides that I worry about for this equation here, and I care about the 2 sides, right? So again, I have five sides total. I have the base of the pyramid, which you can't see, obviously, and then I have the front and the back sides, and then also the left and the right sides here. So that's what we're talking about here. So this is the front and back. This here would be the other 2 triangles on the side, and then the base here would be half of the length instead of half the width, right? So you have these 2 angles here, these 2 slant heights here, and we know that the area of a triangle is simply a equals half bh, right? So half times the base times the height. So you can calculate the area of the front and back triangle using a equals half bh, where you know that it's half of the base times the height, right? You know the base here is going to equal, again, for the front and back triangle, it's equal to half the width, and then for the side triangles, it's equal to half the length, right? So you can plug those guys in, and you would get this formula here, and then you simply just add them all up. So you have this guy plus the length plus the length times width. So this here is our formula for the surface area of our rectangular pyramid here. So solution here is correct. It's a good analysis as well. And again, you're not expected to kind of derive these equations such early on, but it's also good to see where they're coming from, right? Like this formula, you can kind of break this down into, this is the area of a rectangle, and these guys here are the area of the two triangles that exist the area of the 4 triangles that exist on the sides, right? And they calculated this using a equals half bh, where the height is simply just the slant height. And slant height, that you have to use Pythagorean Theorem to figure that relationship out. So the solution is correct. Good analysis as well. Number 7. So it says, how many ounces is more grammatically correct, is in 500 milliliters. So let's see. Right, how many ounces are in 500 milliliters? So in order for us to convert these 2 guys, we're going to realize first that these 2 guys are in 2 different systems, right? So ounces here are in the empirical system, and liters here are in the metric system. So we want to write down this here is both. We're going from the metric to the imperial, sorry, because we're given our metric here. And both of these guys also measure volume, right? So basically, we need some sort of conversion factor. When we're working with 2 different systems, we need a conversion factor between those 2 guys here. And this here is, it's saying here there is 0.033814 ounces in 1 milliliter. And I'm just going to double check that for you. So I'm going from basically milliliters to ounces, and indeed it is 0.033814. So this is our conversion factor. So we can say that 1 ml equals 0.033814 ounces, or OZ here. So in order for me to convert 500, I'm going to have to use some unit analysis, right? So if I have 500 milliliters, I'm going to multiply that by, again, I have 0.033814 ounces per milliliter, and I wanted to get ounces as my units. So I'm going to put here, this would be 0.033814 ounces in 1 milliliter. And this will here, this here will give me my my ounces, right? Because my milliliters here cancel out. This here would equal ounces, right? So I'm simply going to do that on my calculator. I have 500 multiplied by 0.033814, and this will give me a value of 16.907. This here is in ounces, and this here is our solution. As you can see, this solution here is correct because they did the exact same thing. They didn't put the units in the step here, which I kind of like to do to use unit analysis, so I know for sure that I'm getting my ounces here. So this solution here is correct. Good analysis. And again, I don't think you're supposed to memorize these conversion factors. It's mostly for mostly something that you can kind of Google, or if they do, then they'll probably give you some type of formula sheet before you start a test or assignment or whatnot. Okay, how do you find the square root of 21? And this here, again, you can either use the long division or simplified radical form. So firstly, I'm going to use the simplified radical form, and I don't think we can actually simplify this even down further because I'm taking 21. It's not an even number, so I'm going to use I'm going to take out a 3 here. If I divide it by 3 here, I'm getting a 7. So 3 root 7 doesn't really help me here because I can't combine anything. So root 21 is actually the most simplified form. So therefore, we have to use the long division, right? So I have 21 here, and then I'm going to do a long division here to find the square root of 21. So again, I'm looking for two numbers that square closest to 21. 5 squared would be 25, which goes over, which means 4 squared is my only answer here. So 4 squared here would give me 16. 21 minus 16 here equals 5. I would add 2 zeros here, and then I'm going to double my answer here. So I'm going to have an 8 here. And now it's asking us 8 times 8, and what value will give me 500. So I would do 81 times 1, which is 81. 81 times 2 would be 82 times 2 is 164. 83 times 3 is 249. 84 times 4 would be 336. And 85 times 5 would give me 425, which is probably the closest number because 86 times 6 would give me 516. So I'm going to have 85 here. So I'll put a 5 here. And another 5 here. This would be decimal now. 4.5. 85 times 5 would give me a value of 425. So now I'm going to add 2 zeros, and then I'm going to double this amount, right? So so 85 here. If I double 5 here, I'm going to get an 810 here, or 90 here, sorry. Because I'm doubling 5 here, which will give me 10. Or you can think of it as adding your 5 here. And then finally, I'm asking 900 something to 75 here, right? So 900 something, I believe it's times 909 times 9 would give me 8181. So I'm going to go 908 times 8 here, which would give me 7264. So the solution, so I'm going to have 8 here. 8 here, 908 times 8 gives me 7264, and this will be our remainder of 236. And this here is our correct answer. So this here is 4.58. So our answer here equals plus or minus 4.58 approximately. So this solution here is correct because again, square root of 216 here is, or sorry, square root of 21 here is equal to 458. So this solution here is correct, or 4.58. So this solution here is correct. It's good analysis as well. Good analysis. Number 9 is asking us, write the slope-intercept form of the line that passes through 1/3, 4/5 with a slope of m equals 1/4. So I want, basically, I'm given a point here, so 1/4 and 1/3 and 4/5, and my slope here, I'm going to write m here equals 1/4. Oops, 1/4. So in order for us to solve this guy here, what I'm going to have to do is I'm going to first have to use my slope of the equation in slope-intercept form, right? And the reason why I use slope-intercept form is because I'm already given my slope. So I know that y here equals mx plus b. I know my m here is equal to 1/4, right? 1/4 x plus b here. And all I'm going to have to do is isolate for my y-intercept here. Because again, I'm given my point here, and I know it's going to pass through these two lines. So these two, sorry, this solution here. So this x and y coordinate solution here is indeed a solution into my equation. So I can plug in the y value. And as you can see here, this here is my x, is my y. So my y value would be 4/5. So I'll plug in 4/5 here, equals 1/4. X here is 1/3 plus b here. And all we're doing is we're doing some simple addition for us to figure out our b value here. 4/5 equals 1/4 times 1/3 will give me 1/12. Plus b, and b here would simply be 4/5 minus 1/12 here, which would equal 4/5 minus 1/12, which gives me a value of 43/60. And I believe the solution here is correct. Again, this here solution is correct, so 43/60 is correct here. And finally, I can write down the equation of my line, right? So saying here y would equal, so therefore y would equal, again, my slope was 1/4 x plus 43/60. And this here is my solution for the equation of the line. So this is my solution for the equation of the line here. Again, they got the same solution as well, so the solution here is correct. Let's look at number 10. I think I have 3 more problems for today. Probably bring us to 11 here. This, double check, it's number 10. Yeah. It's asking us how much is 168 centimeters in feet and inches. So we want 168 cm, 2 feet and inches. So again, this here is, again, I have a, this here is, I'm going from the metric to the imperial, right? And both of these guys measure the length. So again, cm here is the metric system, feet and inches are indeed the imperial. So again, I need conversion factor, right? So I know my conversion factor is 1 cm here is going to equal basically 1 divided by 2.54. 1 divided by 2.54 inches, which will equal 0.393701 inches. So what we can do with this information is we can convert the centimeters, right? So if I have 168 cm multiplied by, again, I have 0.393701 inches in 1 cm, and I can solve for my inches here, right? So again, the cm's are going to cancel out, and I simply just have to multiply through. So I have 168 times 0.393701. This is going to give me 66.142 inches. And then finally, what I have to do is I have to convert this into, I want feet and inches, right? So now I'm totally in the imperial system. I can convert this guy into feet and inches as well. So again, I have 66 6.142 inches. I'm going to multiply that by how many feet are in 1 inch. Well, I know, or so how many inches are in feet. I know that there are indeed 12 inches in a feet, right? So I can say here, in 1 feet, there are 12 inches, right? So again, these units cancel out, so I can simply divide both of these guys here. So 66.142 divided by 12 will give me a value of 5.51 feet. So I'm gonna, in this case, I'm gonna round down, right? And the reason why I'm rounding down here is that I want feet and inches here. So I'm gonna round down to 5 feet. 5 feet. Which will equal, again, 5 feet here equals simply just 5 times 12 inches, which is 60 inches, right? So in this case here, my final answer is I have 5 feet, 5 feet here, which is 60 inches, and I'm going to subtract this number, right? 66.142 minus 60 here, I'm left with 6.142 inches, so this would be around 5 feet and 6.142 inches here. So you can basically say that, therefore, our solution is 168 cm equals about 5 feet, 6.14 inches here. So the solution here is correct. They actually wrote only feet here, so I don't think they give me inches, so I'm going to say solution here is incomplete. I don't know if they want feet and inches or feet, or is that separate, but maybe I'll say solution here is correct and they just misunderstood the problem here. I'm going to add on to their answer and say 168 cm equals 5.512 feet. So therefore 160 cm would equal 5 feet and 6.142 inches here. The solution here is correct. That was number 10. I think I have 12 problems in here. I'm not sure. I believe I have 12. 12 or 11 or 12, I don't remember. How many cups are in a quart? And again, this here we are in the imperial system, measuring volume. So it's asking us how many cups are in a quart, right? So again, I can write down my conversion factors here. I know that 1 gallon equals 4 quarts, and that's the unit of interest here. 1 quart here equals 2 pints, and 1 pint here equals 2 cups here. So given that information, I'm simply going to convert quarts into cups, right? So given this information, I can do my unit analysis now, right? I can say that in 1 quart, I'm going to multiply that by how many pints are in a quart? Well, I have 2 pints in a quart, right? So 2 pints in 1 quart. And then finally, how many pints are in a cup? Well, I have 2 cups in 1 pint, right? And this here, again, you can see here, my quarts cancel out and my pints cancel out here. So I'm left here with only cups here. So I'm simply doing 1 times 2 times 2, which is 1 times 2 is 2. 2 times 2 here is 4. So therefore, it's going to equal 4 cups. So this, you can write your solution as, therefore, 4 cups in 1 quart. And this solution here is believed is correct. Again, they said 1 quart equals 2 times 2 cups. So this here is 4 cups. So the solution here is, the answer here is 4 cups, not 32. So they wrote their solution wrong here. So I'm going to say solution is correct. Final statement is wrong. There are 4 cups in 1 quart. So I'm going to say solution is incorrect just so they can kind of correct this guy here. And then finally, this is number 12. I'll finish the problem off with number 12 here. It says, given the right angle M and L, what is the value of cos M and sine M here? So I have this right triangle. So I have this right triangle here, and I have, so this is my right triangle, M, N, and L, and I'm given what is the value of cos M and sine M, and this angle here is M, right? So this here is angle M. So I want the value of cos M, and I want sine M as well. So an easy way for us to figure out what these values are is I'm going to use this mnemonic called Sohcahtoa. Sohcahtoa. I'll explain this. So Sohcahtoa. So these, you read this in threes. So this here is sine. This here is cosine. This here is tangent. So here is sine equals opposite over hypotenuse. So sine equals opposite over hypotenuse. Ka here is cosine. So this block here is adjacent over hypotenuse, and tangent is opposite over adjacent. So OA over A. So in this case here, I'm looking at cos at M, right? So cos at M here is simply just the adjacent over hypotenuse, right? So this would be adjacent, which is, you can think of it as MN, over the hypotenuse here, which is M to L, right? So M to L. So this is our cosine kind of ratio, and sine here would be the opposite, so N to L, right? Opposite of this M here is N to L, divided by the hypotenuse, which is M to L here. And these are my solutions for this problem here. So these two guys are my solutions based off Sohcahtoa. So again, sine opposite over hypotenuse, cosine here is adjacent over hypotenuse. So as you can see, these are the correct solutions. Cos M is Mn over Ml, which is what I have here, and sine M equals NL or Ln over Ml. So these two solutions are correct. Good analysis. So that takes me to about an hour. Again, thank you so much for tuning in to the stream. Again, my name is Joey, and I'm a teacher at OneClass. Again, I stream basically Monday to Friday. Monday, Wednesdays, and Fridays are my math sessions, while Tuesdays and Thursdays are my chemistry sessions. And you can feel free to check out our YouTube channel at youtube.com/OneClass. You can find all our videos and all our past videos on that channel if you want to re-watch something or whatnot. Again, thank you so much for watching. Stay safe, stay healthy, have a great day. Take care.